In this video, I'm going to show you how to train and process a Stardist model. So here we are on Jupyter Notebook at the GitHub folder root. So I'm going to click on Stardist and I'm going to open the training notebook. So again, everything is organized the same way. So I'm going to first run the panel to load all the Python packages and the codes we need. And then I'm going to define the parameters. So it's first three ones are all the same for training. I'm first going to define a training directory. So if I go in nuclei segmentation E2F, so I have a training that actually has all the confocal and whitefield images. So then if I don't define the validation directory, we use this parameter to define which proportion of data in the training directory is used for validation. But here I have validation directory, so I'm going to select it for validation. And then the output directory for the model. So I'm going to select the models directory. So we have one channel learning rate. I'm going to keep this value. So again, it would be a good idea to try several values. Number of epochs, I'm going to reduce it because here it's just for demonstration, but obviously you could have more epochs. I'm going to use data augmentation, so I'm going to keep it checked. Batch size, I have a small GPU and not that powerful GPU, so I'm going to keep it to 1. And with final parameters when you don't have a validation directory. Now I'm going to train my model, and so you have a bunch of messages, warnings, as usual. Now I'm just going to speed up the video so you don't have to wait for the actual time for training. All right, so now it's down. As you can see, we have all these last values. We could directly look at it there, but we can directly launch a TensorBoard. Again, I'm going to stop it and rerun it. And so as you can see, we have many different values. So you could look at all those values, but if you want to keep it simple, best way to go is to look at the loss and the validation loss here. So when you look at the loss, you see that it's going down. It's still decreasing, so it probably would be a good idea to increase the number of epochs. When we look at the validation loss, it's pretty similar, and the values are also pretty similar. So here, we use data augmentation, which probably helps, but definitely more epochs would potentially lead to better accuracy. Anyway, I'm gonna now segment images with these models. So I'm gonna close this one and shut it down and open the running. And so first, so I run the first panel to load everything we need, and then go to the parameters. So here the input directory, it's going to be test. The input model is the one we just defined. So it's in this folder. So I'm just going to select the folder, and the name of the folder is again given depending on the parameters. So one channel with this learning rate with data augmentation for 100 epochs, and that's the time when it was launched. Output directory, I'm going to define one because there are no ones there. So if I go back to my folder in here, if I go to Stardist and datasets, here I'm going to add a new folder which I'm going to define as results. So I can now select it. All right. And then you can change the probability threshold and the non-maximum suppression threshold. So I'm going to keep these values and just run the model. on this 6 images. So you see it's processing the first one and then the other one. So it always takes a little bit more time for the first one because it needs to load the model, but then it's pretty fast. And so we can look at the results. So here we directly have a different intensity for each individual nucleus. If you want, you can change the lookup table with class B and dark, so you have a different color. So you see it's pretty good. That's for a confocal image, and I'm going to directly open a wide field image. And so here we had both confocal and wide field images in training data sets. So you see that works. It looks okay. Let's just open the images as well. So this one is this. So we can see that seems fine, but for example here we have 2 nuclei and that's only 1 here, so it's not perfect, but it looks pretty decent, I would say. And that's the second one. And so again, you would have to look to more details. First look, it looks pretty fine, but we see that, for example, here we don't have, we have region without nuclei. Where clearly there are some nuclei, but just the model wasn't able to differentiate nuclei, so at the end we just have nothing. Again, we could change parameters, especially here we could have increased the number of epochs, which would probably have led to better results.